In this lesson, we will explore the methods to calculate the future value of investments or loans using both simple and compound interest formulas. We're going to start with simple interest. Now, looking at simple interest, before we even begin, it is important for us to reflect and look at some financial vocabularies, starting with principal. The principal is the amount of money that is borrowed or invested. The interest is the money earned from an investment or the cost of borrowing money. And the amount is the total value of an investment or loan. The amount is given by, the final amount is always that principal you've borrowed or you've invested, plus the interest you've gained on that investment. Simple interest is an interest earned or paid only on the original sum of money, which is the principal that was invested or borrowed. The simple interest is given by the following formula. Interest is equal to, you take the principal amount, the money borrowed or invested, times the rate, which is always expressed as a decimal, times your time, which is always expressed in years. Total amount of invested earning simple interest is given by the following. Amount is equal to the principal plus P times R times T, which is simply that interest. It's that formula above. If we factor out a P, so we divide both by P, we would end up with A is equal to P times 1 plus RT, R times T. Total amount A and interest earned I are linear functions in terms of time, so their graphs are straight lines. The values of A and I at the end of each interest period form the terms of two arithmetic sequences. Communication tip. The interest rates are sometimes abbreviated. So for example, an interest rate of 4%/A means 4% per annum or per year. Let's rearrange a simple interest formula to solve for each of the following variables. We know interest, I, is equal to the principal times the rate times the time. So remember, this is all multiplying. So then if we want the interest, it would be P times R times your T. If we wanted to know the rate, so if we cover R in the triangle, we're left with I over P times T, so principal times time. If we wanted the principal, I over R times your T, and likewise T would be I interest over P times R. Those triangles kind of helpful to decide, help you rearrange to solve for the unknown. We're going to do a little bit of practice because we know time always has to be in years. So we want to practice converting. Express the following lengths of time in terms of years. T in the simple interest formula. So 24 months, we know there are 12 months. So the conversion equals 1 year. So we take 24 months. We want to make sure the months are eliminated. So we're going to say 1 year. There are 12 months. Crossing those months off, we're left with 24 over 12 years. Well, 24 divided by 12 we know is 2. Good. 8 months, same idea. We're going to multiply by 1 year. There are 12 months. The months cancel out, and we're left with 8 over 12 years. And of course, if you can reduce it, please do. So that would be divided by 2. So 4, no, divided by 4, not 2, even smaller. So 8 divided by 4, which would be 2, 2/3 of a year. All right, so now let's apply this to example 1. If we were to invest $1,000 that earned simple interest at a rate of 5% per annum per year, how much interest and what amount would you have after 1 year? So again, we're talking about simple interest. So interest, P, we know is 1,000. So we've invested 1,000. The rate is 5%. So remember, you divide that by 100, which would be 0.05. And T is the time, and it says after 1 year, so T is equal to 1. If it was given in terms of months, weeks, days, you have to convert the time to years. Now, interest then would be Principal times your rate times your time. Principal of $1,000 times 0.05 times 1, which would equal to $50. That would be the amount of the interest. The total amount, of course, is your principal plus your interest. So we invested $1,000. We made 50. So in total, it's $1,050. Okay, so remember these are word problems. So we do want to answer the question, how much interest and what amount would you have after 1 year? Therefore, after a year, you would have earned $50 interest and a total amount of $1,050. Okay, moving on to number 2, we have Kevin invested $4,500 in a 2-year regular interest Canada savings bond that earns 7.5% annually. How much interest did he learn? So again, we know the simple interest formula is I is equal to principal, so it's 4,500. The rate, which is 7.5%, but we divide that by 100%, which is 0.075. And of course, it was 2 years, so T is equal to 2. Okay, so interest would equal to P times R times T. Principal, which is 4,500, times the rate, 0.075, times 2 year, which is equal to 675. Therefore, Kevin earned $675 in interest. Okay, how much will the investment be worth at the end of the term? So again, that would be your final amount. So the investment would be worth the principal plus the interest. The principal, which is 4,500 plus 675, which would be 5,175. So how much will the investment be worth? Therefore, Kevin's investment will be worth $5,175 at the end of the term. Good. Example 3, we have Madeline has a credit card balance of $550 that was 31 days overdue. The annual interest rate on the credit card is 23.9%. How much interest did Madeline have to pay? So notice it's 31 days overdue. So when you're looking at that, 31 days is not in terms of years. So we have to make sure to express time in terms of years. Okay, so again, we are looking for the interest. The principal we see is 550. The rate is 23.9%. Notice a very high percent for credit cards. So it's going to be 0.239. And the time is 31 days. Okay, so we know there are, in 1 year, there are 365 days. So therefore, T is going to equal to 31 over 365. So the principal, which is 550, we're going to take that times the rate, which is 0.239 times, and I'm going to stick with using brackets, times 31 over 365. I recommend leaving it as exact so we don't round too soon. And we know with money, we round to 2 decimal places. Okay, so multiplying 550 times 0.239 times 31 over 365, we would have so interest is equal to, you would get 11.1642468. And because we are talking about money, we round to 2 decimal places. So the interest is equal to $11.16. Therefore, Madeline had to pay $11.16 about, interest. Okay. Explain why paying interest on an outstanding credit card balance is sometimes referred as the cost of borrowing money. Okay, so that interest is basically the fee of spending using your credit card. Okay, so the interest, we can say the interest is the fee that the credit card companies charge for borrowing, for using the borrowed money, which represents the cost of borrowing. Keep in mind, the longer you borrow the money, that means you're not paying it back in time. The longer you take to pay it back, the more it's going to cost. Looking at example 4, we have 5 years ago, Jasmine lent Jennifer some money. Jennifer repaid Jasmine a total of $2,100, which included simple interest charge at 10% per year. How much did Jennifer originally borrow from Jasmine? So this time we're not asking for the interest, we are asking for the principal amount. Okay, so we don't know what P is. So we can say A is the final amount, which is $2,100. We don't know the total interest. Okay, we also, in that case, we need the principal, which is interest is principal times the rate. We do know the rate times the time. So the rate we know is 10%. Again, divide that by 100, which is 0.10. And we know it took 5 years. Okay, so with that in mind, we would want to use the formula A is equal to P times 1 plus RT. Okay, so we know what the final amount is. It's 2,100. We don't know what the principal is. 1 plus the rate, which is 1 plus the rate, which is 0.10 times T, which is 5. Okay, so simplifying there, we want to always follow bedmass. We're going to take 0.10 times 5. Say 2,100 is equal to P 1 plus 0.5. Simplifying further, always following brackets, bedmass, so brackets is first. So 1.5, we need P by itself. I'm going to divide one side by 1.5 to get rid of that coefficient 1.5. What we do to one side, we have to do the other. So when we take 2100 divided by 1.5, we're at 1400 is equal to P. So therefore, Jennifer originally borrowed $1,400 from Jasmine. Okay, so that would be simple interest. Compound interest works a little bit differently. So let's recall again, simple interest. If you were to invest 1,000 that earns simple interest at a rate of 5% per year, how much interest and what amount would you have after 1 year? So the solution would be take 1,000 times 1 plus 0.05 times 1. We learned it was 1,050. What happens, however, if you want to know how much your investment is worth in 2 years? Unfortunately, simple interest is used only for the time periods of 1 year or less. To go beyond 1 year, we must employ compound interest. Now, compound interest works in your favor because compound interest is an interest that is calculated on the principal and on the interest earned at the end of each compound period. So you're building your money, so your principal, you start with the new principal amount that includes the interest. So you're earning interest on a larger amount. Compound period is the length of time for which interest is calculated before accumulated. Future value is that total amount A of an investment after a certain length of time. The future value of investment earning compound interest is given by the following formula. So the future value, which is the amount, is equal to the principal times 1 plus I, which is that interest rate per compounding period expressed as a decimal, all to the power of n, which is the number of compounding periods. So when interest is earned on interest, we say that interest compounds. This is an example of a geometric series in exponential growth. So compound interest is given by, again, interest is equal to the amount minus your principal. Interest is always equal to P times 1 plus I to the exponent of n minus that principal. So that tells you how much you've made, how much money interest you've made. Or modify that, which is I is equal to P, 1 plus I to the exponent of n minus 1, if you factored out that P in both. So we need to know compounding periods. Annually would be 1 time a year. So you're going to take the annual rate divided by 1. You're going to take the number of years multiplied by 1. Semi-annually would be 2 times a year, so 2. So you would take the annual rate divided by 2 and the number of years times 2. Quarterly, that just means you're earning interest 4 times a year. You're going to take your annual rate divided by 4 and the number of years divided by 4. Monthly would be 12 divided by 12. Okay, you could also have weekly, which would be 52, or daily, 365. Okay, let's find out what the amount would be after 4 years using the compound interest. Okay, so with that in mind, we're now looking at compound interest formula. We know the initial amount, which was $1,000. With simple interest, we earned only $50. So let's see what happens here. We know the interest rate was 5%, so 0.05. And again, it's compounded annually, so n is 1, which is equal to 0.05. And then we also want n, which is the number of years. In this case, it would be 4 times, it's because it's annually, would be 4 times 1. Okay, so then we use the new formula and we want to know, the principal. A by accident, I meant to say P for principal. We don't know the amount, and that's what we're trying to figure out. So using the compound interest formula, we can say amount is equal to principal 1 plus I all to the exponent of n. So we're investing $1,000, 1 plus I, which is 0.05, all to the exponent of n. Now again, just a reminder that 1 is that compound period of annually. So simplified, then always following BEDMAS as equal. 1,000, 1 plus 0.05, which is 1.05, all to the exponent of 4. So keep in mind, again, always following BEDMAS. We did brackets, next would be exponents. So amount is going to equal to 1,000, taking 1.05 to the exponent of 4. We would have 1.21550625, multiplying that by 1,000, and we're left at, again, remember it's money, so we're rounding to 2 decimal places, 1,215 point, because it's 0.625, rounding properly, would be 51 cents. Okay, so therefore, after 4 years, the investment would grow to about $1,215.51. Okay, so let's practice this. We have find the amount of each investment. We have 2,000 invested at 4.25% per year compounded annually. Now, in the wording of the question, you will know you're using compound interest over simple interest because it would always say compounded, and then it'll tell you the compounding period, whether it's annually, semi-annually, quarterly, and it would always follow the word compounded, and for 7 years. Okay, so the principal, so we need to know the amount. The principal is how much we are investing. So in this case, 2,000. I is always that compounding period. So if we took that divided by 100, it would be 0.0425. The compounding annually, so you just divide that by 1. Okay, n is the number of years. So 7 times the compounding period annually, which is just 1. Okay, so compounding annually. Keep that in mind. Okay, so amount is going to equal to the principal, 1 plus I, all to the exponent of n. It's going to be 2,000. 1 plus 0.0425, all to the exponent of 7. Simplifying, 1.0425, all to the exponent of 7. 1.0425 to the exponent of 7, which would be 2,000 times 1.338235189. Okay, so rounding 2,676.47. So therefore, after 7 years, the amount of the investment would be about $2,676.47. Okay, notice it says 5,800 invested at 8% per annum compounded quarterly. So this time we're earning interest 4 times a year. Quarterly means 4. So keeping that in mind when we're calculating the amount is what we need to figure out. The principal is how much we are investing, so 5,800. So we're going to take the interest rate, 8% divided by 100, 0.08. Divide that by 4. So keep that in mind. That's very, very important, and long as the time as well. So we're going to say n is equal to, it's 5 years times that compounding period of 4. So then the amount is going to equal to P times 1 plus I, all to the exponent of n. 1 plus 0.02, all to the exponent of 20. 1.02 all to the exponent of 20. Again, taking 1.02 all to the exponent of 20. 5,800 times 1.4859473996. If we multiply that by 5,800, we have amount is equal to about $8,618.49. So therefore, the final amount of the investment is about $8,618.49. Right, this time we're given principal is going to be $150,000 invested at 7.25% per year, compounded semi-annually. So semi-annually would be n is equal to 2. So keep that in mind. We take the pi is going to equal to that rate. So if we divide that by 100, 0.0725, divide that by 2, which is 0.03625, and which is the number of years, 11 times that compounding period 2, which would be 22. So amount is going to equal to principal 1 plus I, all to the exponent of n, 150,000, 1 plus 0.03625, all to the exponent of n, which is 22. Okay, so then if we take 1.03625, all to the exponent of 22, A is equal to 150,000 times 2.188869946 times that by 150,000, and we are making a lot of money. $328,330.49. So therefore, the final amount of the investment is about $328,330.49. Okay, we have Jada has 2,500 to invest now. She wants 5,500 in the bank in 4 years for college tuition. What interest rate compounded semi-annually does she need to 2 decimal places? Okay, so we have a little bit of work here to do. We're looking at, we know the principal is going to be 2,500 because that's what she's investing. The final amount that she wants is 5,500. Okay, we know that the time is 4 years. We also know then that she's compounding it semi-annually, which is 2. Okay, so remembering in our formula, I is always the rate divided by the compounding period. We also know that time, okay, n is always the time times the compounding period. Okay, so we can fill in some work in here, the final amount and the principal. We know amount is equal to principal times 1 plus I, all to the exponent of n. Now, I is always the rate divided by the compounding period. So we're going to say amount, which is 5,500, is equal to the principal, which is 2,500, 1 plus r divided by 2, all to the exponent of 8. And we need to solve for that rate. Okay, so we're going to use our mathematical skills to isolate and get r all by itself, because that's what we're solving for. So we'll start with dividing this side by 2,500 to get rid of So we're going to get closer and closer to the r, so that cancels that out, which is great. Now, let's try to see if we can simplify that. Okay, so 11 over 5. I'm going to leave it exact. We don't want to round too soon. Is going to equal to 1 plus r over 2 all to the exponent of 8. Now, we need to get rid of that exponent of 8. The only way we can do that is to take the 8th root. So we're going to take the 8th root of this side, and that will eliminate. But what we do to one side, we must do to the other. Okay, now if I take 11 divided by, that's 2.2, so we can simplify that. So we take, so the 8th root of 2.2 is equal to 1 plus r over 2. So if I take the 8th root of 2.2, 11 over 5, I'm going to get 1.103577494 is equal to 1 plus r over 2. Now, keeping in mind, you don't want to round too soon. Okay, so that leads to inaccuracy. We're going to round at the very end. We're going to bring that 1 over. So then you subtract. I know it's a bit tedious writing down all the numbers, but you do want to make sure it's as accurate as possible. So we're left with 0.103577494 is equal to r over 2. In order to get rid of that 2, r divided by 2 on one side, when I bring it over, I'm going to multiply. So it's going to be 2 times is equal to r. So multiply that by 2, and we get 0.20715498883 is equal to r. Now remember, we're going to have to multiply by 100 to get the rate in percent, because that's how we describe it. But when we use the formula, we have to make sure we get rid of the percent sign. So it's 20.71549883. We can bring that percent sign is equal to rate. So we're going to round to 2 decimal places. So the rate is about 20.72%. So therefore, Jada needs an interest rate of about 20.72% per annum in order to have $5,500 in the bank in the 4 years in order to go to college.